Okay, so we're going to start by talking about factors. So if I gave you a number, let's say the number was 12, and I ask you, what are the factors of 12? Does anybody know what those are?
Is it like 3 times 4?
So 3 times 4, 2 times 6, 1 times 12. These 6 numbers are the 6 factors of 12 because they can be multiplied to make us get a 12. If I gave you another number, let's say that number was 8. Okay, what are the factors of 8?
8 times 1.
1 times 8, 2 times 4. So a lot of times, if we're going to have more than one term in a polynomial, we will want to factor that polynomial into its more basic form. We are really going to be undoing distributing. So if you guys will remember, we worked so much on how to distribute to get it out of parentheses. Now we're going to be starting where it's not in parentheses and working back to put it in parentheses. So again, we're going to be undoing distributing, essentially. It's just a new skill. It's going to take some time, some repetition to get it. What you got to be good at is knowing how to multiply and how to distribute so that way we can undo it. What we're going to be doing today is we're going to be looking at multiple terms, and I'm going to be asking you what is their greatest common factor, or their GCF. That stands for the greatest common factor. So in this situation, if these were my two terms, 12 and 8, what is the greatest common factor that they share? Okay, well, their greatest factor is 12. Do they share 12 though? No. What's the next biggest factor? It's an 8. Do they share 8? No. What's the next biggest factor? 6. Do they share 6? No. What's the next biggest factor? 4. Do they share 4? That means 4 is the greatest common factor. What I can do, if I look up here, what number goes into both 12 and 8? That would be 4 is the biggest number that goes into both of them. 2 also goes into both of them. It's a common factor, but 4 is their greatest or the biggest common factor. Are there any questions about how to find a common factor when you're dealing with numbers? What if I gave you 9 and 15? What is their greatest common factor? Don't say it out loud. I'm going to give you, I don't know, 10 seconds. Can you come up with their greatest common factor? So what multiplies to be 9? 1 times 9 and 3 times 3. What multiplies to be 15?
1 times 15. 3 times 12.
So what is their greatest common factor? What number do they both share that's the biggest? 3. So we could say their greatest common factor is 3. Okay? Everybody good with identifying them? Now, if you're not good at this, you need to know, how can I check in my calculator? Well, if I had the number 9, you could just do 9 divided by 1, 9 divided by 2, 9 divided by 3. And whenever you get whole numbers, when you do the division, that's how you know it's a factor. Because sometimes we are going to get pretty big numbers here too. All right, so let me go here to the next level. Let's say I had 12x plus 24. So now I'm writing it like a binomial, like a polynomial that you've been seeing. So this is my polynomial, 12x plus 24. And I'm told to factor this. That means I need to find what is the greatest common factor that both of these terms share. 12x and 24. They do both share 6, but 6 is not the biggest. They do both share a 12, and 12 would be the biggest. So 12 is their greatest common factor. So eventually you're going to get to where you don't have to list them out like what I was doing before. If you struggle with it, I would say list them until you get good at it. But for me, I can look, 12x and 24 have a GCF of 12. So here's what factoring out a 12 looks like. Remember I told you it looks like the opposite of distributing. We are undoing distributing. We're going to take that GCF of 12 and we're going to pull it out of the parentheses. It goes back to the front.
Okay.
And now to figure out what goes inside the parentheses, I'm going to divide both terms by this GCF. So what is 12x divided by its GCF 12? It's 1, so we're left with 1x or just an x. Then I had a positive 24. What happens if I divide that by 12?
Plus 2.
I'm left with a positive 2. So you could see this looks like something we would want to distribute.
That's easy.
What is 12 times x? 12x. What is 12 times 2? So what I did is I undid the distributing. This is called factoring. Okay?
Got it.
Okay? Now, the next thing I want to show you is what if I had x squared plus x? And I was told to factor.
Who is eating chips?
So here, they both have a coefficient of 1. Right? So there's no reason to worry about factoring a 1 out. We never care about factoring a 1 out because it doesn't do anything. If I put a 1 in front in parentheses, what's in parentheses? It's still what we started with. Right? So a 1 is not really useful for factoring.
Would you take the...
Okay, but when I look at their variables, do they have a variable in common? They both have an x. What is the highest power of x that they both share?
1.
X to the first. This is x to the first. Can be written as x to the first. This can be written as x to the first. So their GCF here would be an x. So we would factor an x out. Now if I take an x away from x squared, what am I left with?
X.
I still have one x remaining. I still have an x to the first. If I take an x from x, what's left? Only the coefficient, the positive 1. Because x divided by x is 1. And again, how can you always check this work? Well, if I think I factored it correctly, I can always distribute to see if I get back what I started with. What is x times x?
X squared. X squared.
X squared. What is x times 1?
1x.
Positive 1x, or just x. So you see, if I distribute this, I get back what I started with. This is a good way to check your work. The greatest common factor. So here, if I'm told to factor this, now I have 3 terms. So every time you factor, you're told to factor, the first thing you're going to look for, is there a GCF? Because if there is, that's the easiest way to factor. So let's look at the coefficients between 12 8 and 6, do those coefficients have a GCF that they all have in common? What is it?
24.
That's the least common multiple.
Oh.
Their greatest common factor is 2. They all share a 2 because they're even. Right? We'd want to try 4, but 4 doesn't work with 6. Right? And then 6 doesn't work with 8. So the greatest common factor for the number part is 2. Now we also need to look at the variable part. Do they all have a variable that they have in common?
X.
They all have an x. And so what is the highest power that they all reach? That they all reach. Do they all become x to the 5th? No. Only x to the 3rd is the highest one that they all have in common. So we're going to factor out an x to the 3rd. 2x to the 3rd is my GCF. They all have a 2 in common. They all can reach x to the 3rd. So now if I go back to my original term, 12x to the 5th. If I take a 2x to the 3rd out of that, what am I left with? So I'm dividing, right? I'm undoing distributing. So I'm dividing. I have the number part. 12 divided by 2 is 6. And then x to the 5th divided by x to the 3rd is x to the 2nd. You see how I took 12 divided it by 2? I got 6. Then I divided x to the 5th by x to the 3rd. Remember, what do we do when we divide powers with the same base? We keep the base the same and we subtract the exponents. It's the opposite of multiplying, where we add the exponents when we multiply. We subtract the exponents when we're dividing. Okay, now we go to the next term. It was an 8x to the 4th, and I'm taking out a 2x to the 3rd. So 8 divided by 2 is a positive 4. X to the 4th divided by x to the 3rd is x to the 1st. So that's a 4x. Now I have a negative 6 divided by a 2. That's a negative 3. And then x to the 3rd divided by x to the 3rd. That's x to the 0, right? Not just 0, because 0 would make all that term cancel. But it's x to the 0, which can write as 1. I didn't forget an x.
Why is there on X? Oh.
Because I divided x to the 3rd divided by x to the 3rd.
Oh. Okay.
A way you can check. If you would have had an x there, this is wrong. If this was a negative 3x at the end, what would you have gotten if you distributed? 2 times negative 3 is negative 6. X to the 3rd times x is x to the 4th. Remember, you can always check by distributing. I can't say that enough. As you're learning, getting used to this, once you think you factored it, distribute it just to check your answer. See if you get back what you started with. So this here would be my answer. That is factored.